My presentation is going to be sort of one level down, which is about systems and about actually implementing things and connecting things together. I'm not talking today about the human side, the governance and the process that leads you to have a program, but how do you actually build one? And especially I'm going to talk about reducing the information technology, information management costs to make it a little bit easier to introduce. Keep in mind that really the technology costs are not the major costs in implementing a system. It's the human cost. It's the time spent doing things. But people get hung up on buying things, right? A lot of the human cost is more invisible. So as the introduction said, I'm Daniel Elroy, President, CEO of North-South GIS. We go by a shorter name now, NSGIS. Been in the GIS industry for the past 30-plus years. And over the last 20 years, I've helped start 4 different consulting companies, GIS consulting companies, geospatial companies. And for the past decade, I've been focusing to a very large extent my and my company's efforts on the ports industry. Now, I know not everybody here is from ports, but I saw on the list, how many ports are still here today? You're from Orange and Houston and? Okay. And any others? Port Arthur. Okay, and I saw there was somebody from Corpus Christi. Thank you for coming all the way. What I'm going to be talking about really applies to things, any what we call cities within cities, right? So a port, the correctional facilities down the road, and the one beyond that, and the one after that, and apparently there's another one behind that. These are all cities within cities that have to figure out how to manage themselves in much the same way as cities already do. So I'm going to talk about the information management role, both the required and the optional components. There's a lot of boxes on Roop's screen, and it can feel a little overwhelming as to where do you start, and when arrows point in many different directions, it can be a little overwhelming. So my arrows only go in one direction, right? They don't go in multiple directions, Roop. And then I'm going to talk specifically about the impact of cloud computing on the access and the cost of these systems. But before we get into that, I'm going to start with some pictures, because we could all take a little breather from words and go into pictures. So imagine that we were going to talk about one kind of asset, land. Usually when you think about assets, we talk about cranes and marine structures and all these things that we build and then we repair, demolish. Land is, in ports and many other organizations, the most valuable asset, right? And we have to manage it. Even land does not stay static. It either is improved by some force or it deteriorates. And we're talking about developed and undeveloped land. So very similar characteristics to a crane or a dock. So what would a good strategic asset management program look like for land? So let's, I probably didn't want to press that button. There we go. So let's look at a kind of a visual dashboard of your port, of the land in your port in this case, okay? Suppose that you could bring in the revenues from your billing system and plot them on the map and visually look at it. You'll be able to ask questions like, which property assets appear to be valuable to us? Anybody care a guess? Sure, that's the top earner. It's the brightest red. If you could bring in information from your lease management system that now not just shows how much money we're bringing in, but what acreage you've leased out, you can divide one by the other, and you go, well, now interesting, which is the most efficient earner? It's actually this one, not the one to its right, because we make less money, but it's a much smaller footprint. So there's some higher value in that land. Also here on the left, there's a surprise earner. It didn't really show up before, but now we're seeing there's something good there. And that can lead us to think, well, what can we do like that elsewhere? We make more money for less space. If we're able to bring in, oh, and by the way, that obviates also the losers. You probably already know which ones are the losers, but it obviates it, right? It shows these 3 areas there are white, we're not, or there's one on the right, we're not generating revenue. What's up with that? So now if you're able to also bring in the maintenance costs from your computerized maintenance management system or work order system, you could ask questions like, which assets cost us more to maintain? Now, of course, talking to you before, this assumes that all these systems communicate to the same areas by the same polygons. Of course they don't. We'll talk about that later. But suppose that you could see that, for example, that's an expensive piece of land to maintain, whereas others are less. Well, subtract expense from revenue, and what you have is cash flow. This is a visual profit and loss statement for your facility, right? Because it shows that you have good cash flow over here, you have the best cash flow over there, and then you have trouble over there, and you have trouble over there. Sometimes it helps to see it. Now, if we stopped over here, and where's my pointer bit? Oh, this one. Thank you. If you saw this, you might jump into action and go, we must lease this out. Quick, we need to generate cash. Likewise over here. That might not be the best answer. Because if you're able to now bring from your asset register the asset values, you might be able to see some new things. For instance, this piece of property is valuable. It's losing money on a monthly basis, but it is valuable. But this one is not valuable. It's a liability. Okay. Now, in fact, if you then brought in other liabilities, cash liabilities, loans, bonds, could be qualitative liabilities. It's an eyesore. The neighbors don't like it. It smells. We want a boat ramp there, not a rusty old facility. And if you can take the qualitative, turn it into numbers, subtract one from the other, you then see that. Okay, move on. Oh, it's a little bit delayed here. There we go. You get the net asset value. And now you're making different decisions because now you can see that that lot there that was losing you money, it's still a good asset. So we should just focus on cash flow. Let's get it rented out. Let's clean it up, mow the lawn, repave the road because it's a good one to keep and we just need to fix a short-term problem. That one is losing us money. It's a liability. People hate it. Let's turn it into a marshland or a wetland and put some ducks in there. It'll be great for everybody. This one is a good cash generator, but it's most neglected. Therefore, that's the place to reinvest. Okay, so this is actually your balance sheet, your company's balance sheet on a map. That is, if you could do all those things that we talked about and bring them together in one place and everything is communicating, that's what it would look like. So let's move on from there. The role of information management in the strategic asset management program is to take decision-making away from being 100% intuition-based or gut feel-based and move it into the data world. I'm not saying eliminate intuition. I mean inform intuition with data. As Tom said, in the next, 40% of their workforce at Port Houston is going to be eligible for retirement in the next 7 years, I think is what he said. So you really can't, even if you could rely on intuition in the past, which is also arguable if that was always the best way to make decisions, that's not going to carry us forward. Never mind the fact that the new generation coming in wants data, doesn't even want to necessarily drive things by that. So in order to support decision-making with data, as you saw before, you need lots of data, both quantitative and qualitative. I'm going to use 7 points again and again in this presentation for talking about how to store, locate, identify, and describe assets. Because in order to manage them, you've got to do all these things. You have to do them in sequence. I'm going to go through each one. It's practical. Then show you examples of how a large port has done this and how a large port outside the U.S. has done it and how a small port in the U.S. is doing it. So let's start by defining what the asset is. You have to decide what is an asset. If you work in ports, you know that a berth means something entirely different to the person working on land than it does in water, right? The berth is the thing where you put the ship. No, the berth is where the warehouse is or where the cranes are. No, the berth is the edge between the two. Definitions matter. And you need to decide what gets mapped. You're not going to map everything, but you better map some things so you know where they are. So decide what gets mapped, what gets identified, and what only gets described on an as-needed basis. So I'll give you an example. Here's a port. This is your entire portfolio of assets. Within that, you have an asset system. A terminal is an asset system, at least by my definition. You don't have to agree. You have to decide for yourself. Within that, you have a subsystem, like a berth is a subsystem of assets. Then we finally get to an asset, a crane. Within that, you have components, like the cable winch. And within that, you have the elements, like the motor. All right? So you have to understand, you have to be able to describe it and define a hierarchy that you can live with and that you can sustain. I'm going to introduce a term, granularity. Where do you know granular from? Sugar, right? How big do you want? Do you want powdered sugar where you can't even see the grains, or do you want the little grains, or those, really special ones at the fancy restaurant that are all brown and large? That's granularity. You have to decide how granular is granular enough, right? So you want to be able to break down your data into small pieces, but you don't want to describe them in such small parts like bolt number 771. No, that's ridiculous. Nobody's going to keep track of that over time. It's going to cost you more to collect and maintain. However, you don't want to describe, this looks like a pretty new building. There's probably somebody here that, probably some, politician who's going to be able to say, we spent $15 million on this building. Well, you want to break it down to something a little bit more granular than we spent $15 million in the building. So choose by your ability to have value from that data granularity and ability to maintain it, but also make it small enough that you can build it up in different pieces just like Legos. If your pieces are any of you who've played with your kids or yourselves with Legos know, if you only have the big pieces, you can't do anything interesting and just stack them up. But if you have your data in small enough pieces, you can go, well, this part of the, this was one terminal, for example, and we have, all these facilities on there. But we're thinking of carving this off and renting this or leasing it to somebody else. Well, can we add up just the value and the cost of just these things in here? Well, if you haven't broken down your data to things that can be aggregated in different ways, you can't do that kind of math. And of course, if you get this wrong, you'll have this poor guy over here that doesn't even fit, because you can't stack that on that. All right. Let's talk about that was just defining your assets. Now let's talk about identifying them. Identifying them can be challenging. As Tom said, with a signpost that had 5 different names for the same thing. Identifying an asset when you first put it in, you give it a name. Oh yes, it's the new crane at Ports America. Well, Ports America, terminal operator for those of you not in the ports business, moved on 10 years ago. But the asset description, the identification of it, is still the Ports America #2 crane. You get new people and they go, oh, where's Ports America, right? So identifying things, and I think Tom, it's too bad Tom is gone, or else I could have told him that I disagree with him, that the way to identify things is not just to come up with the same name, it's to stick it in the ground. Because it doesn't matter what you call it. If you can map it, that thing is there. You can call it Bob, or you can call it crane. It's there. And that's one of the keys that, of course, somebody with my background in mapping things and geospatial approach feels that location is the most stable way to identify things. It's not perfect because look at this series of aerial photos from the Port of Los Angeles over 25 years. Look at how it's changed over 25 years. There's nothing stable about a port, right? You could stick something here today on land and it's water tomorrow, or water here today and it's land tomorrow. But it is still the same location on Earth. So that's a key. It's very important. Here's a Maximo, a work order system from some port client, and they had an oil-water separator, and they sent the maintenance person to go look for it. And it's good because the identification had log yard. They didn't have it on a map, but they had described it by location. And the person went out and went, it's here somewhere. I don't see a log yard. That doesn't exactly help me. Eventually he found it. But we looked at old aerial photos. Ah, yes, there was a log yard there. So there's an issue with naming or identifying things by name, because then when things change, you have to go and retype things in databases and spreadsheets for things to still match up. So by virtue of just putting it on the map, that really helps. All right, then you need to locate it. Geographic information systems is the technology invented 40 years ago to store and manage things spatially. That you don't need to describe it because it is there in the XY coordinate, and the relationships between things are based on sort of map layers. You want to see all the high-mast lights that are on the east end of this terminal? Well, then just draw a line around them and it'll pick them up. You don't need to go look through a spreadsheet and find all the names, right? You just do it on the map. So here's an example. Aerial photo. On top of it, there's a map layer for buildings, and there's a building. It's mapped, and you can find out who the owner is because there's a database record for it. And here are the cranes, and you can find out who the manufacturer is or when it was installed. You can look at your hidden assets, your utilities, your underground utilities, your storm drain system, attach photos, have cameras, their fields of view. Everything fits on one infrastructure, right? Even your leases, even your property management fits on top of this. What's leased, what's not leased, even the history of leases. So everything shows up in one place. After that, after you locate it, you need to describe it. Sometimes, going back to this, sometimes describing it in the database is good. That's with a GIS. It combines databases with maps, okay? But many other times, you have to have documentation. Files like manuals, parts lists, product descriptions, leases, drawings, all the stuff on a CAD drawing that doesn't fit in a database, all the squiggly lines and the insets and all that you can never move into a GIS. You need to do something with it. Field observations from inspections, red lines, all these different things. And there are different tools, different software tools for storing those. Such that these documents, right, instead of just being in a file system, that you can actually bring them into the GIS. So sometimes it makes sense to take a CAD drawing and do what we call georectify, just kind of twist it and turn it and fit it on Earth. So you haven't actually converted this digital file or this PDF, but you've put it on Earth, so you can actually derive some information just by. Here's the high-mast light here on the aerial photo, and here's the light on the drawing. And you haven't converted anything, but it is a lot more accessible than just by going to look for the document. Or you can convert the data into line work, real GIS line work, where you can click on things and get database values. Or you can combine the two, or not or, and you can combine the two, convert critical information into digital GIS data, and link to see all the documents associated with that location so that you could retrieve them by location. Okay, so those are aspects to do with describing your assets. Now let's look at how to value them. So valuing your assets usually means linking your assets to your ERP, your enterprise resource planning, or your general ledger software, and to your, again, maintenance management system, your work order system. So systems like you'd recognize some of these names, SAP, Dynamics, NetSuite, JD Edwards, or on the work order system like Maximo and Infor and so on, to get the depreciated value, original value, replacement value, and all that. So you want to bring those together. And I'm not going to bother going through all the different methods. It gets pretty technical. But suffice it to say that some of these systems you can embed a digital map, and that's how you link things. Some are sitting next to a digital map that can be linked. I think that's enough detail on that. And then you need to assess it. So you have everything defined, identified. Now let's see, because what Tom was talking about and what Chuck is going to talk about is assessing it. But long before that, somebody had to map it, identify it, locate it, right? Now we get to the assessment. So the assessment has to do with inspections, and usually Ideally, it's using software, not just clipboards with paper anymore, but that happens a lot as well. To do field inspections, to take samples, but there are technologies that are replacing the need for some of that. So remote sensors, IoT stands for Internet of Things, all the gadgets that we have that transmit things, right? Well, sensors can also transmit. So you can put compression gauges, tension gauges, inclinometers, vibration, resistivity, all these things on bridges and piles, and you can do some of the condition assessment remotely. You also can have crowdsourced assessment. I know there's a lot, I'm throwing a lot of acronyms and buzzwords on you, but crowdsourced is basically your Google Maps and your Waze. You're consuming information from other people. You're also providing information to Google or Waze by virtue of turning on the app. You're one of their measurement tools, right? Well, the same can happen with assessment of conditions. Talking to a mine in Canada, they put sensors in their haul trucks, and when that haul truck goes over a pothole or slows down for some reason that you can't even see, it's reporting the location and maybe the bump, right? So now we know about potholes without ever driving the road. Or maybe there's something else there that's slowing us down. Maybe the turn is a little too sharp. And finally, a ripe source of information comes from mining data we already have in our work order system, in our warranty repairs, our insurance reports, and things like that. So these are all sources of assessment. These, of course, here are some examples courtesy of WJE of their people doing assessments and marking things up on photos, which Chuck will talk about, and on plan maps from CAD, and marking the areas of different issues and quality. And then that will transfer to an overall system. Okay. Beyond assessing, you want to project what it means to the life cycle, projected life cycle of the asset and the costs, so you know how much time you have, presumably have, before something fails. So if it's in relatively good condition, but you've taken some samples, well, this one is not in good condition, but over here you may have taken a sample and you've predicted you have so long before failure. That's one of the ways to interpret this information. Okay. Finally, when you have all this information, this is all talking about the IT approach, not the people approach, you can manage it. You bring it all together so you can ask questions like, which asset has the greatest risk? Which mitigation will be the most effective? What has the greatest positive or negative consequence? As you talked about positive risks, right? New term for me. And then with a finite budget and resources, how should you prioritize? How do you communicate these to people? That's the end goal, right? And you saw a visual representation of that with those maps at the beginning, right? We kind of overly simplified it. So there are systems out there that combine these things. Here's your risk matrix that Roop was showing, and then combined with maps so we know whether, for instance, whether several assets that need repair are clustered around each other. You'd probably want to prioritize those a little bit higher because you can go hit them all at once, right? That you could tell from looking at a map. All right, so the challenge of linking asset information is, first of all, what we said about definitions. What is it? You call it a tomato, I call it a tomato. Let's call the whole thing off, right? I mean, you have to agree on what you call a berth. I think one of the things that happened in Port of San Diego that GHD was involved with is that they spent several months, I think it was there, arguing about what a berth was, right? Agree on the granularity of data. Oftentimes it's not at the same level. The asset register will often have 20 computers, for instance, as one one item in the list. They're all depreciating at the same rate. How can you tell if one goes out of service? I mean, that's just an example. It's very common to have that problem, whereas in a work order system that's reactive, very often people only put things on the map, even if they even put anything on the map, once they've been called to repair it. They don't start with a complete inventory of the assets and then go to it, pick it, and say, yes, I fixed it. They go on a blank map, blank list, then they put it on, which makes it hard to correlate data between different systems, as the discussion was with one, the gentleman from the Navy. The other thing is, and this is what Tom was talking about, if you start with nothing, you have to convert data from digital data, like from CAD. You may have to go out there with GPS and a camera and capture it in the first place, and then you have to maintain it. So these are all challenges specific to assets. But even with information management, you have silos because different systems are managed by different departments that didn't necessarily correspond to each other, and they have different versions that don't talk to each other. This is not meant to be a depressing slide, but these are the things that have to be overcome. Lack of enterprise approach. I was asked the other day, what does enterprise approach mean? It means that it's not locked up in one department without access to the other departments. It means that it's not a information management system that was put there in spite of the IT department, because the IT department was too much of a pain to deal with, so we did it over here. Okay, that's not enterprise. Enterprise means that it's using standards, that it's what's called open architecture. Systems can talk to each other. The other thing is that there is, of course, a prioritization of things over information. People think of information as secondary to the value of another thing, another crane, another fender, another road repaved, because people can see that and they can experience that. But we know that there is a tremendous amount of value to information. Certainly we believe that. Let's move on. So I want to give you an example of kind of the gold standard in strategic asset management programs in ports. And if those of you in ports have probably heard of this, because they never stop talking about it, but for good reason, and that is the Port of Rotterdam. So the Port of Rotterdam, about a decade ago, started building, and then in 2014 released the first version of their KMS, their key wall, or what we call wharf management system. And I'm borrowing a lot of slides, and this is being videoed, and there'll be record of this. I'm borrowing a lot of slides from Henk Vogt, who's he's in charge of asset management at the port there, and I've seen him, talked to him many times. I visited the Port of Rotterdam, so I'm borrowing some of his slides unbeknownst to him, but it's all the honor is to him. So one of the first things one of the first slides that he showed is that the foundation of a strategic asset management program are these three information technologies. An ERP, okay, enterprise resource planning, that can encompass your financial system, it can encompass work order system, HR, parts, right? It's what keeps track of all the bits that cost money and need to be allocated. So systems like J.D. Edwards and PeopleSoft and SAP and Oracle and things like that. The second one is your DMS, Document Management System, also known as eDMS, Electronic Document Management. That term has now been replaced by eCMS, Electronic Content Management System, whatever. And the third one is Geographic Information Systems, the digital mapping and database system. So in their case, more specifically, their ERP is SAP, a large system, large, expensive and complex system, but very comprehensive. Not common in US ports. I only know of, I think, one port, which is San Diego, that uses SAP. But you'd be more familiar with in large ports, like in Houston, I forget what they use, but like I said, systems like Oracle. And then their GIS is ArcGIS, and their document management is the Microsoft SharePoint. Below that is where the expert systems go. So let's go to that slide. So this is the KMS. It's a cycle that sort of goes like this in a figure 8. It takes 1 year. I'm not going to describe all the details because I wouldn't do them justice. But basically, it starts with planning. What are we going to inspect? Go ahead and inspect it. Send it to the lab. Do the prediction of the remaining life on the assets. Do the simulations of what would happen if we do or don't repair, replace, or ignore. Then put it into a financially driven system that helps them prioritize, put it into the budget, go fix it, start again. Now, so what does it look like? First of all, everything is GIS based. So the inspections, everything is mapped in advance. They are particular, the KMS is specifically for the water-land interface, so it's inspecting especially the deterioration and damage to concrete and steel, which then leads to, they use a system called Stadium to project the anticipated life cycle or remaining life on each asset, which then goes into another system called A-Improver, an expert system that has for each item, this comes from the ERP and from historical information, what would this cost to fix or replace or the consequence of doing nothing for each item. And it's very, very granular and very accurate because it's based on just a massive amount of information. And from that, they go into prioritization, and it's a cyclical system. So just to very quickly kind of summarize, relative to those 7 points we talked about before, in terms of definition and identification of assets, they decided on 3 classes of assets: land, water, and land-water interface. And within each one, they decided to restrict, as far as I know, to 10 asset types in each. So on land, for example, you'd have roads. In the water, it might be berths, and then in the interface, it's fenders. Their system of record for locating is the Esri GIS system. Their system of record for describing is SharePoint. And for valuing it and everything related to that is SAP. And then these other 2 systems I mentioned before for assessing and managing. What are the outcomes? I don't have hard figures other than it's a wonderful system and everybody wants it. But they like to quote the fact that just in reductions in costs of inspections, because now they do inspections based on risk, not based on just mere schedule, they saved 3.3 million euros. I don't know over what period of time. I'm guessing that they mean every year, which is not hard to believe for the size of the Port of Rotterdam, the largest in Europe. There is information, all this information is now accessed by hundreds of people daily, anytime, anywhere, meaning on all devices, not just in the office. And they're serving thousands of map images daily. In other words, people are using maps for everything. Data is updated as it is collected, which means analysis is based on real or near real-time data. And the decision support system that tells them what they should work on next feeds on real-time costs and costs of parts and labor from the ERP and the work order system. So this is a well-oiled machine. The rationale for risk assessment, data or intuition, very heavily on data and on formulas. This is from their slides. These are some other items that they listed as benefits: transparency in the whole process, the just-in-time inspections, which reduces the cost, insights into the costs of associated maintenance is basically what I already said. So what are the challenges of translating that into the US? Nobody here is on the level of the Port of Rotterdam. Now, Port Houston, at $333 million in revenue, is getting close. Rotterdam is $750 million. So it's in the same class, right? But there are not a lot of ports like Port Houston. It's a very affluent port. It is not beholden to any particular city or county. It's a national port. It's actually co-owned by the city of Rotterdam and the country of the Netherlands. So that means they don't have, what they want goes, right? And they don't really have internal competition. Their competition is themselves. They're the ones who can shoot themselves in the foot by being inefficient, non-competitive, and then Hamburg and Antwerp will take over. But within their ecosystem, they're their own worst enemies. And so, they have no physical capacity to grow. So the only place they can go is in efficiency. So that's why they're pouring so much of that money back into this. So, hard to do here. So, what is cloud computing? We're kind of making a jump here. What has cloud computing done to help reduce the cost of a lot of these technologies that I've talked about? First of all, before I even go to the first bullet, I should have put a bullet before the first bullet. Ports in the US have been leery of cloud computing, not understanding what it is, not knowing if it's safe, not knowing if it's the right time or whatever. I sit on the AAPA IT committee, and so I listen to the CIOs talk about it. There's been a big shift in the last 3 years, more or less, towards acceptance of the cloud. Not only is it inevitable, but it is now policy of many government organizations, state governments, go cloud, because it saves money, big money. Also, the web and the cloud have spawned these 3 lovely acronyms: IaaS, PaaS, and SaaS. Everybody know what all 3 of them are? No? Okay. So yes, I know somebody does. IaaS is infrastructure as a service. You don't buy the server, you rent it. Or you subscribe to it. You don't really rent it. You subscribe to a server in the cloud. So you never have to pay for the infrastructure. Platform as a service, a little bit harder to explain, but it's kind of like subscribing to Oracle or to SQL Server database. It's a platform on top of which other things go. But again, you're not buying it. You don't have the person to run it. You're not worrying about upgrades every 3-5 years. And then the most common one that probably most of you have seen is SaaS, software as a service. You don't install it on your PC. It lives in the cloud. You don't buy it for all the people that you do or don't have working for you. Just subscribe for the number of people that you need. And this is, the cloud isn't what made this. It was really the web that made this possible, but the cloud is what has made it very inexpensive. So only pay for what you use, and you pay as you go. So there's much less capital investment, if any. The initial cost, therefore, is far lower. The expertise no longer has to live in-house, because what the heck? Your hardware is not there, the software is not there. Why does your person have to be there? You basically can rent or subscribe the person to maintain it as well. That also gives you the ability to switch directions and switch software much more easily. You made the wrong decision. It's not sitting there. You stop subscribing. You migrate to a new system. Not that that's easy, but you're not stuck with, well, we have to depreciate this thing for another 3 years, right? The other thing is that cloud computing has spawned what's called open architecture in software. Software that can talk to software that's never met before, but can get along with it. It's like the ultimate translator at a bar. Meet somebody speaking a different language, you can immediately communicate. So think about what all that has done for Uber, which is not computing, it's cars. But the fact that I only use as much car as I need and when I need it is completely turning upside down car manufacturing, ownership, driving, insurance, all that. And this is what this has done for strategic asset management. So here's an example of a small port. I mean, not small. I mean, it's, I looked at the numbers. It's about twice as large as Beaumont in terms of revenues, about half of what Corpus is, and about 10% of what Houston is. It's about 37 million, 40 million. But it's only 5% of Rotterdam. What chance in hell did they have a few years ago to do anything like Rotterdam with that little money to play with? So they are a client of ours, so a little disclaimer here. That's how I know about what they're doing, because we're doing it to them and with them. They just started this year, and in the initial few months, they already, if you remember the basics, they already will have GIS, document management system, and work order system, and future phases, hopefully in year 2, probably year 3, integration with their existing ERP, and developing these expert systems that connect all this stuff together. Okay? So how are they doing it? First of all, if you see over here, you're not meant to be able to read it. This is their network. Most of the stuff is up in the cloud. So to define it and identify the assets, we're still working on that. So we're progressing quickly. Locating it, they're using, again, Esri GIS software in the cloud. on cloud hardware from Microsoft. The document management, NSG software in the cloud. ERP is Microsoft Dynamics, which will be linked next. They already have it. It's just not linked. The expert system is a future phase. Work order system is something called Elements XS, all in the cloud. The transformation is very rapid. They're going from paper maps and drawings to digital maps. They're going from CAD drawings that only one person has one license of AutoCAD on their PC to all those things being available to anybody who needs it. They're going from the use of spreadsheets to manage documents to a database managing their documents. From searching for documents by the name of the folder and the file as the only descriptor, somebody better had typed in the right descriptor and abbreviated it in some way that somebody else can understand it, to being able to search for documents by location on a map or what we call metadata, information about the documents. Going from work orders by email or phone, radio, to work orders through a work order management system. From taking condition assessments that are done by various contractors and just filing them somewhere to one system to store all of that. And from a system that had no ability to link to financials to a system that will be able to very soon. And from management by intuition to management by data and risk. And finally, this port is a operating port, but they just acquired about, I think, 70% as much more land as their old size, which they're going to lease out. So they're becoming a landlord port overnight. And with this system, they also have a system for managing leases. So this is very rapid. One of the things that helped them very much is that they had very good AutoCAD drawings and they were up to date and they were actually organized well, right? Good place to start. Rare. So takeaways, for about $30,000 a year in hardware and software, they went from having essentially nothing to having a disaster resilient cloud server with Windows on it, for those of you who want to know what they have. Microsoft SQL Server in the cloud, Esri ArcGIS software, including a geodatabase, web mapping, data collection, inspection apps, not specialized inspection apps, not for condition assessment, but just like doing things in the field, recording things. Then these other the other software for 15 people on any device. Now, granted, they don't have that many people working there. I think they have tops 100 people. But a few years ago, this would have bought 2 desktop GIS software installed on 2 computers with none of the rest of the stuff and no connectivity. This is how far we've come in the technology. So when we listen to Roop and we can get overwhelmed by the enormity of the process, we then go, and then we have to learn all the software and then buy it and all this. Things have gotten a little bit easier, and that's the good news. And the question often is asked of me, well, yes, I hear you. All of this sounds good. What's the return on investment? And I turn it around and say, well, what would each of these systems be worth individually? To identify and locate the correct assets when you go repair something. Somebody calls it in. It's the thing. It's broken. You go and fix the wrong thing. To access documents quickly, accurately, and completely when you hand them off as a work packet to a contractor. Or a public records request, and you don't spend all day looking for the documents. You just press a button and give it to them. Being able to record history reliably so it can be analyzed in future. All these different things, right? And how much are these systems worth when put together? So, last 2 slides. Strategies, as was said before, and of course will always be said, is make a plan. Think as an enterprise. We already talked about that. Have the governance that will make thinking as an enterprise possible. Translate intangibles into tangibles because they're important. What I think some people call it the social license to operate, right? You can be shut down if people don't like what you're doing. And so you have to quantify what keeping going is worth and the remediation to that. Agree on definitions, leverage cloud and subscriptions to reduce costs and initial risk, bite only what you can chew. and then get components that stand alone but plug well together. And finally, some industries may not be required, but others will be required, as Roop said, to have a strategic asset management plan, mostly state by state, but it's happening. Strategic asset management reduces surprises, those peaks in Roop's graph, and surprises are expensive. Therefore, whether required or not, asset management plan saves money, increases sustainability, and there's really no reason we can't adopt it in the US. Maybe we have to do it our way and not the European or the Australian way, and that's fine. We may not do it because we want an ISO certification, as is more common outside, but we can use the ISO standard for our benefit, right? And then I would say replace the ROI question with CONI statement. What is the cost of not investing, which was Tom's point. And I think with that, I will take any questions. Now, you're my co-presenters. You're supposed to have one question each to ask me, just to get the audience going. Okay, yes.
So this looks great, but the question I have is data gaps. How would you handle data gaps? Because they can completely screw up the right how you manage it.
Yeah. So obviously, this is the technology. It's not the feeding the beast, right? You have to have a beast, and then you have to feed it. What I would do is kind of like the same as what we talked to. Somebody asked, I think, asked Roop, did you assess the high-risk things first? And he went, well, oh, no, they asked Tom, that's right. He was like, yeah, things that we don't dock ships at, we're not going to assess, right? Not initially. So you do have to prioritize, and you have to focus on your data cleanup and data scrubbing on the areas that are most important to you. Do a pilot. Discover how much error you're tolerant of, because you can be tolerant of error, right? Any machine can have some chatter in it before it blows up. Likewise, you can live with imperfect data. But there's also a mind shift in the personnel involved that finding one error is not, that's it. We never trust this system. And that has to do more with governance and making sure that people in management understand enough of the technology and don't go, oh, yeah, that's you smart guys, you talk about it. No. There's got to be some education at some level that can educate management so that they understand, they believe, and then they can communicate down and say, it's okay if there are a few errors. And the last thing, I know it's a long answer to your question, is build a loopback mechanism into the system that allows people and encourages and rewards people to correct the data when they find it to be erroneous. So a simple markup system on an app that says, I went there and this thing is no longer there, or this was missing. Give them then a loopback mechanism that informs them when that's actually been corrected. In fact, you can, there's a term called gamification, right? Turning things into a game, a chore into a game. Give rewards for the people who turn in the most errors. Make it into a game. So those are three ways of dealing with that. Yes, Roop, over there in the audience. Yeah.
When you deploy different tool sets in the cloud, how do you do the integration in the cloud?
Well, first of all, your servers in the cloud are just your servers. You may think of them as being a little bit further away than you used to, but in fact, when you have 3 servers in the server room or 3 servers in 3 different locations, they still just have to talk to each other. So really, you're talking about security. How do you handle the security behind it? Because if your 3 servers, for instance, are behind your own firewall, you can make it an absolute protection. Probably absolute doesn't happen anywhere except maybe submarines, and there's been things about submarines also not being completely secluded, right? So it's really not, there's no issue with it being in the cloud. It's all a matter of how you handle your security. Yeah. Well, good. Thank you very much.